This is lesson 2.2, Simplifying Radical Expressions. Before we get into it, we'll go over some quick properties of exponents first. A times b to the power of m equals a to the power of m times b to the power of m. Next, a to the power of m times a to the power of n equals a to the power of m plus n. So, both of these terms need to be the same in order for this condition to apply. The next is a over b to the power of m equals a to the power of m over b to the power of m. So this m will distribute to both parts of the expression. This a to the power of m to the power of n equals a to the power of m times n. So these two will just multiply. It's a to the power of m over a to the power of n. A to the power of m over a to the power of n will equal a to the power of m minus n. And a to the power of negative 1 will equal 1 over a. So we're just taking the reciprocal of this. Now that we have that, we'll go through some warm-ups to get used to this. So in the first example, 4 to the power of 3 times 4 to the power of 2. We notice that these two are the same term, so we're looking at this rule here. So we'll take 4 to the power of 3 plus 2. 3 plus 2 equals 5, and we'll have 4 to the power of 5. In the next example, we have 4 over x to the power of 3. Looking at this term here, looking at this rule here, we'll know that this 3 will distribute to the 4 and the x. And we can rewrite it as 4 to the power of 3 over x to the power of 3. If you want to take it further, 4 to the power of 3 is 64. So we'll have 64 over x to the power of 3. For this last example, we'll have 4 to the power of negative 2. When we raise anything to a negative power, we're going to take the reciprocal of it. So we'll look at this rule here, a to the power of negative 1 over a. So we'll put a 1 here to make it easier to visualize. Then we'll have 1 over 4 to the power of 2. Now 4 to the power of 2 is equal to 16, so we can change it to this. Now that we've done a little bit of a warm-up with properties of exponents, we'll move on to some rational expressions. First example, we're going to apply the exponents each individually. Now, if you remember from a previous lesson, this rule, the nth root of a to the power of m equals a to the power of m over n. We can change these Now that we've done a little bit of warm-ups with the properties of exponents, we can move on to rational exponents. So for this first example, we're going to apply each exponent individually. Now from a previous lesson, we know that this rule, a to the power of m over n, is equal to the nth root of a to the power of m. Now if you're confused by this, we have the previous lesson that went over changing rational exponents to radical expressions and vice versa. But with that in mind, we can change this term, 64 to the power of 1/3, to the cube root of 64, and the second term, 64 to the power of 3 over 2, to the square root of 64 to the power of 3. Now the cube root of 64 is 4. And the square root of 64 is 8. We're going to bring over this cube. So now we have 4 times 8 to the power of 3. 8 to the power of 3 is 512. So our final answer is 2048. For the second example, we know that these exponents will distribute to both parts of the expression. So we have 64 to the power of 3 over 2 times 4 to the power of 3 over 2. So we've just actually solved for the 64 to the power of 3 over 2. So I'm just going to bring it down from the previous example, which we know is 8 to the power of 3. And 4 to the power of 2 over 3 is the square root of 4 to the power of 3, which we know to be 2. So we'll rewrite 8 to the power of 3 times 2 to the power of 3 equals 512 times 8 equals 4,096. Now in our final example, we have 64 to the power of 1/3 to the power of 2 over 3. So we'll focus on the inside of the parentheses first. We'll take the cube root of 64, which equals to 4. Now we'll take 4 to the power of 3 over 2. We'll take the square root of 4 and bring it to the power and raise it to the power of 3, which equals 2 to the power of 3, which equals 8. Now instead of going through each exponent individually, we're going to go through the same questions, but this time using the rules of the exponents. So for the first one, we'll notice that this base is the same, and we're multiplying. So when the base is the same and we're multiplying, we can actually add these two exponents. So we have 64 to the power of 1/3 plus 3 over 2. And remember, when we add fractions, we'll have to find the greatest common denominator. And remember, when we add fractions, we'll have to find a common denominator. So if I multiply 1/3 by 2 over 2, we'll get 2 over 6 and 3, 2. And 3 over 2, we want to match this 6. We can multiply by 3 over 3 equals 9 over 6. So now that we've simplified these, we take 64 to the power of 2 over 6 plus 9 over 6 equals 64. 2 plus 9 equals 11 over 6. Now we can change this term using our rule from changing rational exponents to radical expressions as the sixth root of 64 to the power of 11. Now, I don't know the sixth root of 64 off the top of my head, but we can easily factor this out. So 2 goes into 64 32 times. 2 goes into 32 16 times. 2 goes into 16 8 times. 8 can be divided into 4 and 2, and 4 and 2 and 2 here. So we see that we have actually a perfect group of 6 2's here. So now we just have 2 to the power of 11. 2 to the power of 11 equals 2048. Now, if you're lost on any of this, the previous lesson goes a bit more into working with radical expressions and rational exponents. But to continue, we're going to keep applying the rules of exponents to these problems. Now for the second example, we can use the distribution rule and distribute this exponent to both parts of the expression. So we can rewrite it as 64 to the power of 3 over 2 times 4 to the power of 3 over 2. Now, since we're multiplying these two terms, we want to try and get these bases to match. That way we can use this rule, a to the power of m times a to the power of n equals a plus m, or a to the power of m plus n. But here, these two are the same term, and here 64 and 4 are not the same term. So in order to work with this, we're going to try and transform this term to match 4. Now we can break 64 up into terms, and if we want to match 4, we'll try and factor out 4 of 64. So 64 divided by 4 is 16. Then we can break 16 up into 4 and 4. Knowing this, we can rewrite it as 4 to the power of 3, because there's 3 4's, to the power of 3 over 2 times 4 to the power of 3 over 2. That way we can add together the exponents. But first, let's multiply these two exponents together to get it simplified. When we take an exponent to an exponent, we'll multiply these two exponents together. So we have 4 to the power of 3 times 3 over 2, which equals 9 over 2, because there's a 3 over 1, so 3 times 3 over 1 times 2 is equal to 9 over 2. So that's our exponent. So we'll have 4 to the power of 9 over 2 times 4 to the power of 3 over 2. That's this term. Now we can finally use this rule here to apply to this. So since our bases are the same, all we'll have to do is add 9 to the power of 2 plus 3 to the power of 2. 9 plus 3 is 12. 12 over 2 simplifies to 6. So now we'll have 4 to the power of 6, which just equals 4,096. In our last example, when we see an exponent raised to another exponent, we know that we can multiply those together. So we'll rewrite this as 64 to the power of 1/3 times 3 over 2. Multiplying these fractions, we'll get 64 to the power of 3 times 1 is 3 over 3 times 2 is 6. Simplifies to 1/2. So 64 to the power of 1/2, which is the same thing as the square root of 64, which is 8. In these two examples, we're going to combine changing radical expressions to rational exponents and then simplifying from there. So we have three terms to look at here: x, the second term, and the third term. So we'll bring down the x because it's just by itself. Then we're focusing on this one, and we're going to change it to 2y to the power of 1/3. Then on the second term, we'll change this exponent. Now for the second term, we'll change this radical expression to this exponent, 4x to the power of 2 times the power of y, and we're bringing this to the power of 1/3. Now to work through these problems, I suggest memorizing the properties of exponents or having them down on a piece of paper next to you. So to work through this, we'll have x, then we'll distribute this 1/3 to both terms. So we'll have 2 to the power of 1/3 and y to the power of 1/3. Same thing for this term, we'll distribute to all three parts. So we have 4 to the power of 1/3 times x squared to the power of 1/3 times y squared to the power of 1/3. And once we do this, we can simplify all of this as 2 to the power of 1/3 times 4 to the power of 1/3. I'm just going to keep all of the numbers in the front and move all the variables to the back. Times x, so we have this x and this x. This term, x squared to the power of 1/3, is also x to the power of 2/3, because we'll multiply those two exponents together when we raise exponents to another exponent. So that becomes x times 5/3, and now we have these two y's terms times y to the power of 1/3 here, and this becomes 2/3, so 1/3 plus 2/3 is just 1, so we have y to the power of 1. And focusing on this term here, in order to add exponents together, we'll have to make sure that these are the same base. So we can change 4 to 2 to the power of 2 in order to have them match bases. Multiplying these two exponents together, we'll have 2 to the power of 1/3 times 2 to the power of 2/3. We'll bring these down. So it's multiplied by x to the power of 5/3 times y. Y to the power of 1 is just y. Now that these two are finally the same base, we can simply just add their exponents together. So 2 to the power of 1/3 plus 2/3 just equals the power of 1 times x to the power of 5/3 times y. So now the final answer, once simplified, is 2x to the power of 5/3 y. For the second example, we're going to change these radical expressions to rational exponents. We'll have 64y. We're raising that to the power of 1/2. And in the denominator, we have 64y raised to the power of 1/3. We'll apply this 1/2 power to both terms, so 64 raised to the power of 1/2 times y raised to the power of 1/2. We'll do the same thing on the denominator with 1/3. So you have 64 raised to the power of 1/3 times y raised to the power of 1/3. We'll simplify these two numbers. 64 raised to the power of 1/2, or the square root of 64, is 8, and the cube root of 64 is 4. Now we're left with our y's, 1/3 and 1/2. Now when we have a fraction of a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So we see that these two are the same bases, which luckily they are the same bases here in our example. We can switch out the variables. So y to the power of 1/2 over y to the power of 1/3 is equal to y to the power of m, which is the top term, 1/2 minus 1/3. 1/2 minus 1/3 simplifies to 1/6. So y to the power of 1/6. So we can take this term and replace it over here. So let's rewrite this to clean it up a little bit. We have 8 over 4 times y to the power of 1/2. 8 over 4 is just 2, so we have 2 times y to the power of 1/6.